Welcome back, students, to Lesson 5. Today we're going to talk about sets. That's part of what we're going to talk about. The first thing I want to talk about when we say sets, we're talking about a designated, well-defined collection of numbers, objects, or things. That's what the word set means. And we have a way that we write a set that needs to be illustrated. A set is written by giving the set a name. In this case, we're going to call it set A. And we're going to say that that's equal to, and this just defines the members in the set. We put a curly bracket, and then we list what's in the set, and we separate it with commas, and we close it off with a curly bracket whenever we're done. Now, let's say we want to illustrate the set of natural numbers. Right? Those will be our counting numbers. So let's call that set N. And we know that counting numbers or natural numbers start with 1, 2, 3, 4. Well, the set goes on to infinity. So the way that we illustrate that is by putting an ellipse, which is 3 little dots, and then closing it with the curly bracket. So that tells us that it goes on, but it starts here. That's what it's saying. We could say the same thing for our whole numbers. We could say whole numbers, the set of whole numbers is illustrated like this. We say equals, we do a curly bracket, we start with a 0 because whole numbers include 0, and we can use as many whole numbers as we want in the right order and then put in our ellipse and then our last curly bracket, and then that's understood. Okay? So that was how you would write or illustrate a set. Now, what about integers? Because they go on in both directions. So we would write integers like this. We would say, that should be an S. We would start with an ellipse. So on to the left, right? And then we would put a few negative numbers from the number line and 0, and then we move on to positive numbers, and usually you want to balance it, and then we put our other ellipse. So this tells us that the set of integers is 0 and everything to the left and everything to the right of 0. So all the negative numbers and all the positive numbers on the number line. This illustrates that without us having to draw a number line with arrows. So you could type it. So that is how you would want to illustrate sets. When you're asked to write a set, this is what you would do. Okay? So you need to just figure out how you want to draw that in your notes. You could just put this there, or you could illustrate it and say this is the name of the set, the name of the set here, and then equals, that should be a U, equals, and then you're going to have the first bracket, and then you're going to have the members, and then you're going to have the last bracket. So if you want to put that little illustration in your notes on how to write a set, there you go. So if you need to pause, take those notes. I'm moving on to absolute value. So with absolute value, you have to ask yourself, what exactly is the absolute value? Let's say we have positive 7 and a negative 7. And we know that absolute value, you put these little flat brackets on either side. But what does that mean? Okay, they're opposites of each other, right? Not with absolute value. With absolute value, it literally means the absolute length from 0 on the number line. So if you have your number line here, and you have, this is 0, and you have 1, 2, 3, 4, 5, 6, 7. That's positive 7. And you have 1, 2, 3, 4, 5, 6, 7, negative 7, right? And you want the absolute value of positive 7 the absolute value of positive 7 is, it's 7. It's the length of 7. So you would have 1, 2, 3, 4, 5, 6, 7 hops or 7 spaces, units, whatever the measurement is, from 0 to the right for positive 7. So the absolute value of positive 7 equals 7, which is positive 7, okay? So the absolute value of negative 7 is 1, 2, 3, 4, 5, 6, 7 spaces or units or hops from 0, positive 7. A length, this is a length from 0 to whatever number you're asking about. A length can never be negative. It is always positive. And so absolute value is literally asking you, what is the length from 0 to this number? So an absolute value is always going to have a positive value when you solve it. So if you have a negative number, it just becomes the positive number, okay? If you have a positive number, it just stays the positive number. That's all it is. It's very straightforward. It's just the length on the number line from 0 to that number. It doesn't matter whether it's positive or negative. Length is never negative. Okay, so let's do a few little problems using positive and negative in our number line. Let me clear this page. So let's say we have a problem 3 minus 2, right? We have done in elementary where you have 1, 2, 3 pieces of candy and you take away 2, you have 1 left, right? Okay, so we know that. But when we use the number line, we do it a little bit differently. So we have 0, 1, 2, 3, right? So using the number line, you could also use a ruler if you don't have the number line. It's a great stand-in. And let's say we have 3, we want to take away 2, right? It's the same thing we did up here. So we're going to go backwards on the number line because we're subtracting. Think of it like this. It's 3 plus a negative 2. Negative means go to the left. So when you have a positive 3, that's what this is, positive 3 and a negative 2, you're combining them. That's what plus means. That's what addition is. It's combining numbers. When you combine a positive and a negative, it's a subtraction. So technically, everything is addition. You're just combining positive and negative numbers when you subtract. So if you have a positive 3, a negative 2 means you have to go to the left 2 spaces. So 1, 2, that leaves you at 1. Isn't that what we had here? Right? It's the same thing. That's what that is. So on the number line, you start with the positive number or the number first, and whatever this sign is, that's the direction you move on the number line. Let's try something a little bit more difficult. Let's say that we have, let me find another problem for us. Let's say we have a positive 3 and a negative 5. And we're told to add those numbers together, right? Okay, so let's draw our little number line, kind of get our head around it. Now, I know what the answer is already because I know that 5 is bigger than 3. But there are some rules that you want to think about. Here's the 0. 1, 2, 3. That's a 3. And let's do 1, 2, 3, 4. All right. So negative 1 and negative 2, negative 3 and negative 4. When we start with, we could start with a positive 3. And we could go 1, 2, 3. We're at positive 3, right? Now we have a negative 5. We need to go to the left, negative 5. So, or to the left 5. 1, 2, 3, 4, 5. And that's right over negative 2. So combining a negative 3 and a negative 5 is going to give us a negative 2, right? You could also say 3 minus 5 equals negative 2, because here's the rule. When you subtract or when you combine two numbers like this, you have to take the sign of the larger number when you're subtracting. Okay? If it had been 5 minus 3, 5 would be positive, and it's the bigger number, so it would be positive 2. But because 5 is the bigger number and you're subtracting, then it's going to be a negative 2. We could have started with negative 5. It would have been the same result. Let me show you. Take this off. If we had started with negative 5, let's put negative 5 in here, right? And we had gone up, let's just start here at negative 5. And we had gone to the right, to the positive side, 3 spaces. 1, 2, 3. We would have still ended up over the top, or we would have ended up at negative 2. It's still the same answer. So we could even rewrite it. Negative 5 and positive 3 combined is going to give you a negative 2. It doesn't matter. With the property of the commutative property of addition, as long as the sign stays with the number it is in front of, then the answer is going to be the same. Okay? That's how we can move them around. So what you want to think about whenever you're doing these numbers is to, everything is addition, but the sign in front of it, if it's subtraction, it's attached to the numeral that you're working with. Let's do another one. Let me clear this page. Let's do example 5.6, okay? So 5.6, we have negative 4 plus positive 2 plus a negative 1 plus a positive 5. Okay, we need to find our answer. So here's our number line. Let's put our 0 here. And let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, let's start with negative 4, which is our first number. So 1, 2, 3, negative 4, right? Let's come up here. We're right above negative 4. So we have a positive 2. That means go to the right 2. So 1, 2. All right, now we have a negative 1. So we're going to go back to the left, to the negative side, 1. Now we have a positive 5. So we're going to go to the right, 5. So 1, 2, 3, 4, 5. And we are right over the number 2. Okay, so let's illustrate that. We have negative 4 plus 2 minus 1 plus 5. That's our original with these little signs taken out. And we've attached the subtraction or the negative sign as subtraction. So the first thing that I would do when I see this is I would take these first two numbers together. Negative 4 plus 2, okay, that's a negative 2. And then I would go to the next one. Negative 2 and a negative 1, when you have two numbers that are the same sign, the number gets bigger. When you have two numbers that are a different sign, the answer gets smaller. Okay, so negative 2 minus 1 is going to be negative 3. Okay, negative 3 plus 5. This number is bigger, so we take the sign of the bigger number. It's going to be 5 minus 3 equals 2. Let's see if we ended up on 2. We did. That's how that works. Now, because of the commutative property of addition, which means we can move them around any way we want to, you can put your positives and your negatives together. So you could say negative 4 and rearrange it a little bit plus a negative 1. Well, that's negative 5, right? And then you would have positive 2 plus positive 5. That's a positive 7, right? So we've kind of simplified it to -5 plus +7. 7 is the bigger sign. 7 minus 5 is 2, +2. Now, we assume that every number that's written without a positive or negative sign is positive. And we're going to continue in that. So you can write it just like that. And I understand that it's positive. I only need a sign if it's negative. Most mathematics works that way. We only need the negative sign here if it's negative. So you can leave a positive without the plus sign on it, and it's just fine. So that'll simplify your work a little bit as you go forward. But that is how you add or combine numbers that are positives and negatives. It's going back and forth on the number line depending upon the sign that they have. Negatives go to the left, positives go to the right, and you just, if they're different signs, there's some subtraction going on. If they're the same signs, then there's some addition going on, regardless of whether they're positive or negative. So if this has thoroughly confused you, which it possibly could, please feel free to text me and ask me for clarification or additional resources or another video if that helps you. I have some other videos that explain as well, and some other resources that might give you some help. Just look at your practice problems. Go ahead and do those. And if your practice problems, if you can't do them, if you're just having trouble, you're stuck, then contact me and we will figure this out. But ultimately, I don't want to confuse you by having you think about this. If you can add and subtract positives and negatives, do it the way you know how to do it and the way that gets you the right answer. Okay? That's all I have for Lesson 5. I will see you in Lesson 6.